Everyone can hear me in the back? It's fine? Okay. Hello, everyone. Welcome to Hacking MFPs, Postscriptum You've Been Hacked talk. A few words about myself. Somebody of you might know me as MFAQ author or previous Hacking MFPs presentations. And I would like to, just as a warm-up, ask the audience which vendor do you think will be covering. So I'll ask to raise hands for Xerox. Okay. Who is for HP? Oh, much bigger. It's like 70%. And Canon? Like 10% and 5% Xerox. Okay. And one more question is like, how many of you have written by hand any PostScript file, not generated, but written by hand? Okay, it's around 25%, cool. And some PostScript file which interacts with hardware or any weird things, like, okay, 2 hands, 3, okay. So this will be very interesting for you. Okay, so a quick refresher. Why again I talk about MFPs and so on and so on? Well, MFPs, as you might know, printers and so on, are basically essential part of any modern network. And as part of any modern network, it's like a trustworthy resource because it's inside the network. Usually it carries confidential data, confidential documents being printed once in a while, or less confidential data. It's part of the private network of where it is being deployed. It is not very well patch managed, usually. Well, it's because it's seen as an embedded device, and patch management is not very well standardized on those devices. And usually it is, or sometimes it is connected to the public internet, which is very bad. Okay, so the history of hacking MFPs goes back to the 60s, those slightly over 50 years old will be more comfortable with this story. It's like a story from 60s where they spied on Soviet Union embassy. Also, they had a camera, but it's more mechanical camera and so on, some circuitry. And basically, hacking MFPs goes back to the 60s. So, however, modern hacking covers like the last 10 years, like the last decade. And it started around 2002, public modern printer hacking research. And then it kept iterating every few years. And basically, we are now in 2011, 2012, with very revived printer hacking interest. And this particular talk, compared to other talks I've made or other talks available, will mainly focus already on remote code execution on the MFP side. And basically, in 2010, we've demonstrated and we've mapped publicly exposed MFPs and printers. And as you can see, with little scripting, there was like, we've gathered tens of thousands of these. We've mapped them on the Earth. So you can see a big density in Europe of various vendors. Also, we've found ways and demonstrated how it is possible to deliver generic payload to the MFPs using Word documents, and as well as deliver payload to the MFPs in a generic way using Java, and some other researchers demonstrated with JavaScript. So web is also an avenue for this, not only open and print attachments. But this talk is not only about basically hacking MFPs in the generic way, but it has like a PostScript orientation. And what about PostScript? It's basically a general purpose language invented by Adobe in '85. And basically it was one of the first typesetting languages available on the market. And the picture is very representative because it's a picture from the Adobe's presentation of a PostScript, and it turns out that the road of PostScript is as long and it's bumpy and has unexpected turns at the end. So it was somehow prophetic. Again, PostScript, if you have listened to the previous talk, it's a Turing-complete language, and as you could understand from, I'm not very big expert in formal languages and so on, but as you could understand, Turing-complete languages are not very secure, so to speak. But basically, Adobe's implementation of PostScript has the widest share on the market, and it's implemented in most PostScript interpreters and printers and on various workstations doing the formatting. So it's about roughly 90%, according to some supplemental note, it's roughly 90% of Adobe's interpreters versus 10% of other vendors for PostScript interpreters. And the interesting side is basically PostScript being a general purpose language and being Turing complete was built with very generic ideas in mind, and it is built with very powerful capabilities, and basically it has file system or some kind of virtual file system operators and input-output subsystems like Ethernet or serial port, whatever is available on the device. So, and it was demonstrated over time that various complex design problems or complex problems in general have been implemented in PostScript, like seen guys implementing web servers, seen guys implementing ray tracing in OpenGL, guys running PostScripts for the milling machines, XML parsers, or other languages parsers. So it's a very general purpose language and very powerful. However, the specification of PostScript dates back, the latest revision as far as I remember is 99, so there hasn't been too much review in a while, so I would say it didn't quite adapt it to the current security landscape. And one of the things which struck me and us during this research is that the PostScript specification mentions something about the interpreter or a shell or something like this, executive. So if you go to the specification, you'll see clearly that they say you can enter some kind of a debug mode. So if you ever worked with GhostScript, which is a PostScript interpreter for PCs or whatever, maybe you are very familiar with that console which says GS and the greater sign. So basically, you can get the same on the printers, and basically it is designed so that you can debug why your PostScript document is not being properly printed, displayed, or why the printer just spits garbage. So you can enter, or a software engineer can enter the interpreter and see what is the problem, debug the document, and format it properly. But it can be also used to play with the interpreter or find other hidden functions in the interpreter or the printer or whatever. So as far as we have seen various estimation notes is that around 80% of MFPs and printers have this interpreter or executive or shell enabled, and 20 doesn't have it applicable or doesn't have it enabled. So you would ask how to enter this shell. It's quite simple. If you are familiar with PostScript or PGL or PCL, it's a PGL job where you enter the PostScript language, self-explanatory. We have the standard PS Adobe PostScript header, some comments, and then we just write this executive command, and we enter an interactive shell of the PostScript interpreter. So we'll have a demo. So we'll just ping our target MFP. And then we'll just connect it, again, whoever answered Xerox, the vendor we talk about in this talk is Xerox. So those 5% were very close, despite their quite secure products. So, but this code works on HPs, on most HP models and Canons and so on. So we have our PostScript language, we have it, give it a title, and just send this document as a job printing spool on the port 9100. And as you can see, it popped up the interpreter software version and revision and copyright notes and other stuff. So you can basically start running any PostScript code which you had in mind and run this code on the printers itself. So you can do print, or you can do some general purpose computation, matrix computation, and so on, because it's a very powerful language. So I've used few operators like product and version and pstack, which prints the stack, and so on and so on. So basically, you can go to your closest MFP or printer, try this, and you'll get this kind of shell. So you can start fuzzing the interpreter. Maybe there's a bug in interpreter, but the purpose of this talk is not exploiting the bug in specific interpreter. Okay. So what did we find using this approach? So we needed like a PostScript-based firmware upload or a PostScript-based mechanism to execute code or non-graphics code on the MFPs and printers. And we've been looking through the firmware, and it was like tons of downloads until we find a very nice user guide where the vendor tells you, go to the print page. Here's your .ps firmware upgrade, which already raises questions. How a .postscript file should upgrade your firmware. And then in the user guide, we are kind of stuck and see, but they say go, upload it, and hit the print button, because it's usually the file, printing page of the MFP where you can, normal users goes and uploads a text file, a PDF file just for printing, but using the same print page, basically you can upgrade the firmware. And this is the intended mechanism. So we said it's very interesting. Let's see what this PostScript file contains. It's usually 40 or 50 megabytes long. And basically what we found is like a big set of APIs, right? And basically most of these MFPs are implemented in some kind of real-time operating system like VxWorks or LinksOS or some kinds of this. This specific model line implements VxWorks. So we found VxWorks API, debug and QA API, like doing automation tests or performance tests. We found some logging APIs, some pump setup API because it has some pumps for the ink and for other things. We had the RAM disk, RAM, flash, and billing meters API. Billing meters is also a very interesting part because, you know, the counterfeit industry tries to circumvent the metering and original components. So it was like very good to be true in the sense that we got so many API very well linked to the hardware level, but exposed to the PostScript language. And writing PostScript is not very easy, or not very sweet, so to speak, unless you adapt your mindset. But it was very interesting finding. So we just took one part of the API, and we found that it had some memory access, physical operating system memory access functionality. So you can say from PostScript, say, VxWorks, give me bytes from this physical address, and it will give you. So we wrote a memory dumper, which dumps basically the memory. And it is an old technique because, as you might know, once you have the memory dump, you have basically all computation secrets on any computation platform, so to speak, because file system might not be involved, but everything which is in RAM or in the memory is basically a live state of a computing machine. So we said, okay, it's very, very nice to have this memory dumping technique. And then we just sit and wrote a couple of demos, and basically, I'll be showing you the demos. So let's say we have this printer, and it has the administrative security settings where you can say enable the admin password and other power user settings like key user and key password, and we set them. And we disable any user from doing anything normally thought as administrative level operations. We save, and basically we get an acknowledgement that security settings were set on the device. So from this perspective, administrator or whoever is doing a security check says, okay, the printer is like admin locked. It should work fine, and nobody except admin, knowing the password, should be able to do something malicious, right? Because usually the admin interface is something that malicious users abuse. But we go from the back side. We go from the PostScript, from the normal document flow, document printing language. And what we do, basically, we just take our code, we run it. There was a PostScript code which we didn't want at this particular moment to show, and we got a memory dump of whatever is there. So the first thing we notice is that setting an admin password on the web interface doesn't necessarily fix the other modules like PostScript or other modules involved. So we see some different, it's too hot in the room, right? It should be too hot now. Because it doesn't prevent the attack being run on the printer. So it's one of the flaws because it doesn't restrict special operations. So this is just a diagram of the attack that having a PostScript with a bomb inside circumvents the administrative settings and doesn't prevent the memory dumping. So then the next thing is we think that, okay, we have secured our product and we have a password on it, on administrative interface, and let's say we change it regularly, right? We follow our policies, we change it every 30 days or so, we put strong passwords, strong usernames, right? And just for information, the password and usernames were the same, like admin28c3. So, and we log on from time to time just to check that the printer or MFP is fine, right? And we see we've logged in. And now the idea is that, as you can see, that pop-up is usually like a basic authorization, authentication authorization over HTTP. And we just let's compute its base 64, whatever is being sent over HTTP actually, right? Admin username and password. But the attacker can send a very specific print job which dumps a lot of memory and does some searching and so on and so on. And what we demonstrate in this demo is that we dump a specific region of the memory we know, and we take all the memory and using not very smart techniques, and I mean, an attacker can get like access to the password and username, right, from the memory, as you can see, whatever last username or last several usernames and passwords have been logging in to this admin interface, we have them all, right, in the memory dump. So again, having this and using them often basically gives more chances to the attacker to get your passwords, right? So again, do not abuse your admin interfaces to check them often. And we can see other details like whatever browser the admin used, and we can see if the admin can be exploited, and so on and so on. You can think any other scenario. So basically, the diagram is simple. Authorization, OK. We get the PostScript in memory. It gets the password to the attacker. OK, so basically, somebody would think, OK, let's enable HTTPS, right? We'll get everything encrypted. However, we have found, using the same memory dumping technique, that even security protocols are being leaky in the sense that we have found various private keys, like in memory, or IPsec authentication keys, which, again, basically, we don't have a demo which we decrypt the traffic because we didn't have to. We had other simpler means to hack it, right? But again, it's a warning, a big warning. Once the attacker has the secrets from the memory, circumventing file access or any other means is like useless. OK, and basically, we demonstrated that securing the web interface doesn't solve your problem, basically in all the cases, right? So what about somebody printing, let's say, a very confidential and secure document, and so on and so on? We simulate that, and we have found, as you see in the demo, we have a remote desktop. Let's say it's a high-rank official. And basically, the high-rank official wants to print a very secret document. OK, high-rank official has access to the printer. And we'll simulate as he was printing from his preferred document management application, but it's the same thing. Basically, everything goes on that port. And as, let's say, the high-rank official sets a pin for the print job, so nobody can print or take the printout from the machine until the correct pin is entered, or some machines allow you passwords, right? And the content of this document is supposed to be like secured. And even though you think that putting some security devices on both ends so that everything is encrypted on the wire and no Wireshark can sniff it, we are running in the memory. So guess what? At some point, this encryption on the wire gets decrypted in the memory. So basically, whatever is being printed here, his username and PIN and so on, we'll just send it to the printer, and in a couple of seconds, we'll see what actually happens. OK, so the remote desktop, we simulate the printout. The job went to the printer, to the MFP, and I got a paper out of the tested device. OK, blank because it wasn't too much of a thing to draw, like just a move to. On the other end, the attacker connects to the same MFP, OK, having the IP 101, and just running the specific memory dumping code, and on the specific region we have tried to map. OK, just 1 sec. And again, you see a lot of memory dumping. Knowing the memory area gives us a lot of advantage because we can just go and check the details or write a simple matching function, and that's it. And let's say we have in the memory, as you can see, basically in the memory, everything which the high-rank official, so to speak, or victim has printed and thought to be secure, basically it's being clear text in the memory. And as you can see, the attacker also knows the IP from which the secret document was printed, right? And he knows the content, knows the pin code. He can basically harvest pin codes and passwords from this user and get more advanced knowledge. Okay? See? So basically everything is in clear text in memory, even though you might think it goes even encrypted on the wire. Yeah, so basically we have access to the interpreter, memory, and document processing. Okay? So just, it's simple. Password, lock, and encryption goes to the printer, postscript, inside the memory, the printed document goes to the attacker. So it's a very dangerous avenue because basically you understand that data theft is pretty easy. Okay, and at the end you might be asking, for example, okay, an attacker can have the access to the memory, but what more he can do to take the data out? Because what I've been showing is just running some code in the backend, and with access to specific APIs, basically we have found full BSD style sockets. So you can understand that a specific full end-to-end program can take the memory dump, encrypt it for the attacker, or just strip the necessary details, and then send with full BSD sockets to the attacker, and then also use the MFP as internal network scanning or attacking device. So basically, we just show that we ping the device, okay? And the direction in this was from our attacker computer to the printer. And now we telnet to the printer, we run the specific postscript code. Okay, we see that attacker, okay, these ports are open because we simulate that we print something to the MFP. And basically we take the code, run it on the MFP, and as you can see, now the ping request is from IP 102. The ping request comes from 102. 102 being the MFP. So basically, we have full BSD style socket control in the MFP, and it's like a game over, right? You can initiate any kind of raw packet, raw socket, whatever your techniques you know, right? Yeah, so it seems pretty scary if you glue all this code together and run a very simple, small file document. Yeah, this is a simple diagram. So we try to summarize, and basically on the attacks we have been trying on this machine, or on this line of the devices, is the protection measures we try to thought have been easily defeated by the demonstration we have shown. Basically, we have privilege level separation failure, where I showed the administration level not being enough to restrict the memory dumping and other API calls, and so on and so on. So secure password setup, also password is being sent in clear text and intercepted in the memory. Okay, so now from our research, we have found that basically all of these devices and device line is using the same PostScript firmware update mechanism, meaning that all of them share more or less a common base of exposed APIs and APIs which can be used in the same manner as demonstrated in the previous demos. So more or less a generic PostScript malicious program can be written which perfectly or more or less perfectly exploits all of these devices. Some of them have the same device number, but they're different in various configuration, hardware configuration, or VxWorks version, or platforms. But because we have PostScript, which is like a Java for printers, it is like platform independent. Okay, so just to summarize, the attack in the nutshell, in a single slide, would be like this. Like from our 2010 demonstrations, the attacker sends if a MS Word document specially crafted, which has a malicious PostScript inside it, or he can send specific URLs to the victim on the email or messenger where the victim clicks and goes to specific sites. Okay, in the case of the Word document, the user opens the attachment, sees nothing suspicious because there is no computer virus in it. It is a virus in PostScript for mfps, for which we are not aware of any antivirus or IDS or IPS existing on the market. And in the other two cases, it's just a web page requesting you to print something. Think of coupons, right? Who doesn't love coupons? It's like freebies. And the user just print the attachment or print from the web. The malicious payload hidden in the MS Word or Java applet or JavaScript just goes to the MFP and plants the PostScript. And the PostScript, as you can see, could see in the previous videos, can do any kind of malicious attacks on the network itself, and also do data theft, document theft, and so on and so on. So basically, enterprise assets are at risk in this particular scenario. So what we envision next is to put everything together and basically make a kind of PostScript toolkit, having various generic PostScript or Xerox-specific PostScript, which ties together the sockets and file system and other exposed APIs, port at least some Metasploit samples, and just have an attacking demo toolkit for high-level language like PostScript, which can be easily abused and can be a very powerful target even for other vendors, because we didn't test all the vendors and all their other devices. So this kind of scenario would be very dangerous because, for example, PostScript is a Turing complete, and you can basically write some bytes on the stack, then concatenate them, and then apply CVX operator, and everything like string becomes executable, and it executes, and all kind of mess. So it's very hard to actually detect a malicious byte stream, because like you can compose executed programs from any combination of encoding, decoding filters, and various hex byte manipulation techniques. So whatever techniques known in JavaScript and PDF combined and so on, were like easily transposed to PostScript. And as a solutions, basically we have various categories or actors, which we try to give some advice. For example, for administrators, how easy is to defend against these attacks? You'll see in the following videos, but because of the explicit documentation and the explanatory notes missing, it's not very easy to understand what those settings do, so admins just prefer not to touch those settings if everything works. So to defend against this attack is quite simple in the first perspective. So a user can go, if you own a Xerox listed there, I would suggest going right after this talk, and okay, you can leave everything in or whatever settings you have. And there's a thing called language operator authorization. I'm not sure how much does it tell you as an administrator of a device when you have like heterogeneous networks with hundreds of device language operator authorization. So the idea is that you have to uncheck that box so that this kind of attacks will not be possible. However, the idea is simple that the language operator authorization is usually enabled by default. So most probably at the next unsecure patch, it will be enabled by default. And the idea is if you disable it, you cannot actually upgrade the firmware. So to upgrade the firmware of the printer, you have to enable it. And once you enable it, most probably you'll leave it like this or forget about it. Otherwise, you run into other kinds of problems. And this is a drawback. This should be, if the mechanism should be a little bit different, or the documentation should be very easy to understand what this checkbox does. So basically, just unchecking this box will help you to prevent in the short run and mitigate these kinds of attacks. So as you can see, basically, we have this disabled, and you can see we have like invalid access given by the device. So in short term, it's a solution for you as administrator. You have Xerox of these models, go and do this now. Don't forget to enable when you do firmware upgrades. Okay, should look for security bulletins for various vendors, depending how heterogeneous your MFP environment is. It's like keep an eye on HP, on Xerox, on Canon, on every vendors if you have all these vendors in a network, because PostScript interpreters have their own bugs as well, or various customization which has bugs. So it's very, very good to see. Sandbox the printer, so they are either have their own VLAN or have very limited and restricted environment and so on. And very important, include MFPs in the security audit lifecycle. So most of the, because they are not very homogeneous or doesn't have like a very usual security settings, they are often left outside of the security audit lifecycle because it's just a printer, it prints on the paper, but it's, as you could see, it's not the case. For the users, it's hard. You just can advise, but you cannot guard them or beat their fingers. So just have to educate, the managers have to educate the users, or users educate themselves. Do not print from untrusted sources, or be suspicious what you print, especially it's freebie. Okay, and for the vendors, before or during their life cycle, to create realistic MFP threat models, meaning that try to put that MFP in a real-world scenario, a real-world security landscape, because putting it out of a context and checking it for security, right, admin interface is secured, everything is fine, we are great. But if you put it in another context, then it completely changes the game. So realistic MFP threat models is one of the things that can be improved. And other thing, as history has shown over and over again, is that just do not enable or expose or do not use and implement super APIs and try then to hide them. Just don't do this. It's the wrong way of doing, I think. Okay, so we'd like to thank Xerox security team because they were positively on responding to our responsible disclosure contact, and we're very active working with them, and their side is very active in checking the affected user base and propose active mitigations. And basically, what are the takeaways from this talk is MFPs are really, really bad insecurity as we stand right now here in this room. So this has to be understood because in the last couple of years, a lot of MFP and printer security talks evolved and techniques. And we basically want to emphasize that there might be upcoming wave of various security threats targeting MFPs because of their weaknesses. Of course, criminals or others could go for the easy prey, and why not doing this? And basically, the last thing is securing the MFP infrastructure requires better segmentation, strong credential, secure proactive thinking, and basically continuous vulnerability patching in its whole life cycle, meaning from vendor to the client, to the admins, to the user, and so on. So it's not just a target to achieve a security compliance level, but again, it's a whole process in itself. So basically, these are my contact details. If you have any detailed question afterwards, for this moment, I say thank you. And if you have any questions in the room.
Please try to remain seated while the question and answer is ongoing because it's extremely distracting if people are going to leave now en masse. So if you have questions, queue up at the microphones. I'm seeing 2 already. This one was first.
Very interesting talk, thanks. I have one question about something you alluded to in your slides. Given a Word document, how can I embed a PostScript fragment in it that will execute on the printer? Have you explored that at all? Is that an avenue that's actually available to attackers?
Basically, this attack, which you are asking about, Word document, it's been demonstrated in my 2010 and 2011 talks. And in the slides, you'll get a link to the YouTube showing this attack. So it's not theoretical, it's actually practical. I mean, you can, there are really ways, and I'm trying to also, we are trying to go with vendors of Office or whatever, right? To see how it can be solved, but it's like a legacy functionality which has been carried. So it's available, I think, from Word 3.1 or whatever till now. So it's a practical attack.
So the last one, my memory is that you can embed an EPS into a Word document, and that gets sent to the printer raw. Question, how certain are you that the super APIs are only available in executive mode?
Come again, please?
Are the APIs also available outside the executive? And can you prove they're not?
Basically, we don't care if they're, at this particular moment, we didn't care secret or hidden or super APIs being outside of the executive, because once we had them in the executive, it gives us platform independence, and basically it was the thing we found and we explored it. So, but it doesn't exclude the possibility of having other hidden APIs, and just to give you an example, I have seen basically firmware updates where PCL, and PCL being a very, very restricted language compared to PostScript, which is just drawing, right? But even there, I found vendors which have secret APIs and do firmware updates through PCL, which doesn't come even close to PostScript in powerful general purpose or other levels, right? So, of course, there are plenty of them, but because they're embedded system, closed things, very heavy to try to purchase and explore by independent researchers, it's still hidden.
Okay, we are leaving no note behind, so we have a question from the internet.
Yeah, here somebody wants to know if it is possible to change the printer firmware so that the printer can damage itself, leading up to completely destroy itself.
I missed the second part.
The question was whether it's possible for the printer to destroy itself by changing the firmware.
Well, basically, I would not like to comment on this because there was like a big hype, fuzz, and so on and so on. Unless, I'll put it this way, unless there's, okay, just a complete thought. Printer fusers, especially laser ones, have specific temperature ranges, right? Some of them go to 250, some of them go to 270. Normal paper burning temperature depends whether it's surface or there's an ignition source or not, and so on and so on. And putting these things together is hard to say that plain paper would just start burning in the printer. Right? But what I want to say is, for example, imagine if there's a more complex attack where the paper supplier is being actively attacked by whoever and puts sheets of paper with special powder or chemical substance whose auto-ignition temperature is like 230. And there are like 3 or 4 substances which can do this. So in a combined attack, yes, this is pretty accomplishable even today, right? But these are just facts, and unless there's a demo demonstrating this, or unless there's an independent laboratory, safety laboratory, which demonstrates otherwise, it's really hard to tell that, yes, this is true, yes, it's like a P different than P, right?
Okay, but I think this is a very stupid thing, because if I want to burn the printer, I can just put gasoline in there and flame it, and so I don't need to know something about PostScript. But I think there's another interesting thing. Would be interesting to buy exactly the same printer, have fun with a logic analyzer, and modify the firmware. So I have my own printer, modify a firmware, put in some special function that I want to have, and then make a document with this modified firmware, send it to somebody I want to tease, and he gets my special firmware, and I can do some special stuff with his printer. And I think this would be more interesting. And there's also one interesting point, because modern photocopiers and bigger printers have hard disks, and these hard disks store all the jobs. And so if you, for example, go cleaning, you can exchange the hard disks every day. So if you maybe you say I'm a low-skilled worker and I go cleaning, and then you, for example, go for the hard disks. And this would be interesting, for example, to know if they are encrypted or not, and then if they are encrypted, to get the keys from the memory, and then have fun with the hard disk contents.
The points are good. I just want to put one point for each of your part. Basically, indeed, having a custom firmware is interesting, and indeed putting like backdoor functionality there is even more exciting. However, I'll just try to emphasize, which I wanted actually during the talk, is that demonstrations which I showed you relies basically on simple PostScript commands, and I don't even have to know anything about the firmware format, firmware signatures, firmware packing, and so on and so on. I just run PostScript. And this is a very important point, because compared, for example, for other attacks, in order to write yourself a custom firmware, it's not necessarily very easy, because there are, as I said, a lot of steps involved, like understanding the packaging format, understanding the signature, writing the firmware of completely heterogeneous and non-very used hardware is indeed a challenge. And it depends what your scope. If you want to bug, for example, a specific country where you ship a specific model line, of course, there's like all the possibility in this. But if you target only a specific user, there are easier ways to go around. And the second point, what you said about hard disks, actually, it is a well-known problem. And in 2010, there was a big investigation done by CBS in the United States, where recycled MFPs, printers, copiers got sold, and they belonged to government agencies, and there were unencrypted documents regarding criminals and prosecutions and orders and so on. And then it was raised at very high level, And basically, the vendors had to come with military standards for digital information shredding on the hard disk. However, we don't have any independent view and testing results over the efficiency and effectiveness of those shredding techniques implemented by the vendors. They are claiming they are being certified, but there is no independent view on whether these are effective. Of course, you can do a lot of work, and actually this was done by a CBS investigative journalist, and it was proven. So
Are the firmware images somehow signed so that the printer says, no, this is an illegal image, I don't want to print it, and I will go into some debug me service number so-and-so mode, and then you have to call the service. So if you, for example, want to print a money bill, they go also into a special service mode that you cannot print again. And so maybe they, if you want to, so if I would make a printer, I would make it like this, that if you put an illegal image, that it goes into special mode and locks it up.
well, it's again, it's a philosophical problem. What if the same was done for your iPhone, for example? You could never use it again if you put some other firmware or signature checking was indeed enforced, checked, and so on. Would you be happy to have your device locked? It's again, there's no true balance in here, and you cannot lock a user device. However, the takeaway from your question is to have a secure hashing algorithm, not CRC32, and enforce it and check it properly. These are the takeaways. Now, whatever other things are going wrong in that direction is a totally different story, I think.
But you haven't investigated if this is enforced by the Xerox printers?
No.
Okay, we'll do this round robin. There was a question over there, unless it's died of old age. Okay, then we have two questions at the front. One from the internet first, I think.
Well, there is one. Has Xerox did anything against this attacks?
Sir?
Did Xerox do anything against the attacks?
Basically, we are in the process of responsible disclosure and mitigation techniques and affected user base discussion. So, as you understand, it's like a longer patching process, like assessing the risk and so on and so on. So, we are in the process, but it's not yet ended, so to speak.
Okay, a one-time only offer. I bring the microphone to you.
Okay, you have full memory dumps. Can you use them to have a software printer emulator so you can do all the security destruction on the software printer instead of destroying your physical printer, which is fairly expensive?
Well, I don't know how much would destroying a virtual printer would help you in assessing the threat and risk of destroying the physical printer. So, but your first point, which you mentioned, actually is very valid in the sense that because PostScript is a Turing-complete language and it has very interesting primitives, you can actually redefine the language. And basically, whatever the user document contains, like draw this line, put this dash, use this character, you can route everything through your own APIs. So basically, you can write a virtual PostScript interpreter in PostScript and route any of the basic PostScript calls to you and store all the data in the file system for later retrieval. So basically, you do a virtual machine in a virtual machine, so to speak, using simple PostScript. It's a tedious process to write like a PostScript custom virtual machine on top and redefine all the operators and language and so on. But it's doable. There are samples on the internet and it's easy to do.
Okay, we have 5 minutes left. The remaining questions over there.
So you've looked at a lot of these specialized operators in PostScript, and I'm wondering if you've seen any bugs that look like they could lead to native code execution on the microprocessor that's implementing the PostScript interpreter.
So just to understand, if there are any bugs which we can exploit from PostScript to execute code on the microprocessor?
Obviously, the firmware update is one way to get native code execution, but I'm wondering if there's any runtime exploits.
Yeah, basically, in this particular scenario, you don't need even an exploit. And I'll tell you why. There are two things. Actually, you can patch the code in the memory. You can also have write access. And if you know which memory to which device is being mapped, and know that operator opcode language, you can patch it in the memory. This is one. This is an obvious exploit. But the second is everything is running in VxWorks, a specific version where you can run it through QEMU or so on and so on. And there are file system APIs where we can actually write a binary blob to the physical operating system file system. Okay? So you compile an executable for this VxWorks version. You just upload it using PostScript, and basically it executes as part of VxWorks. We didn't go as far, but everything is in place. So with little effort of compiling and uploading is like, you get the point.
Okay, next question.
Yeah, hi. I just like to add some notes on this hard disk issue or question. So I did some research on that with a colleague, and this.
Can you be louder?
I'm just commenting on this hard disk issue, which was just asked before. I did some research on that with a colleague, and this whole thing with secure file management and stuff turned out to be a total mess. So even though the vendors claim to use some secure file management, we were easily able to reconstruct a lot of files. So what they do is they create some kind of a pseudo file system, which is not easily recognizable and looks like something encrypted. However, if we've been working on the raw device, we were easily able to reconstruct file headers and corresponding files. And for several cases, we reconstructed like 10,000 files, which turned out to be basically everything which had been printed or scanned with this device in the last 2 years. So yeah, you would not want to rely on that. So
Exactly. As
it's
mentioned,
basically security by obscurity, and I mean, as we all know, this doesn't work at all. Right?
it has to be independently tested and have a very open guideline for testing and assessing the security of these features, actually.
Yeah, sure. Thanks.
Okay, then our time is up. When you're leaving, please exit.
Thank you again.
Yeah. Big applause.